Changing a single word in your prompt can completely alter the answer an AI gives you. Ask a model to solve a problem, and it works. You ask the same question with a slightly different phrasing, and the logic fails. To fix this, we need to benchmark phrasing sensitivity. This metric tracks how much a model's output fluctuates when given semantically identical prompts, and we are going to build a local pipeline to automate that measurement. To follow this tutorial, you will need Docker, Python, and an active API key from OpenAI, Anthropic, or Grok. Docker is a tool used to package software into containers, ensuring the code runs exactly the same on your machine as it does on mine. Quantifying how a model reacts to phrasing changes provides a measurable baseline of reliability. This data is a requirement for anyone looking to move an AI system from a local prototype into a production environment. Step 1 is cloning the LLM evaluation harness repository. Once the files are on your machine, open the project folder in your code editor to view the directory structure. Locate the file named .env.example in the root directory. Duplicate this file and rename the copy to exactly .env. Open the new .env file and paste your active API keys for whichever language model you intend to benchmark. Never commit this .env file to a public version control repository. If your active keys are uploaded, they can be scraped and used by third parties, leading to significant unauthorized billing. The repository includes a .gitignore file, listing file names that the Git client is instructed to ignore. Because .env is listed here, the system is configured to block your credentials from being uploaded during a commit. Establishing a strict, secure local environment is the first step of this process. With your configuration isolated, you can begin the automated testing phase. Run the command docker compose book-build in your terminal to start the process. We are executing this in an isolated Docker container rather than your local Python environment to ensure reproducibility. This setup guarantees that all software dependencies are identical, regardless of your local operating system. Once the container is active, the system begins iterating through a dataset of 20 unique questions spanning mathematics, logic, coding, and factual recall. The system generates 3 phrasing variants per question. These are sent to the model to see if wording changes cause logic to deviate. To grade responses, the harness applies 2 protocols: exact match, checking for specific strings, and LLM as judge, evaluating the response's logic. Docker is configured to map the resulting raw JSON files directly from the container back into your local results folder as the tests complete. This containerized pipeline manages the API routing and scoring automatically, providing you with a standardized set of performance data. To analyze the data, we will switch to a local Python environment. Run pip install -r-requirements.txt to install the necessary reporting libraries. Execute the command python-m source.reporter. This script parses the raw JSON results and compiles them into a human-readable markdown summary. The report records a flat 0.0 standard deviation in phrasing sensitivity. This indicates that the model's logic remained consistent despite the superficial changes to the prompts. However, question 20, a logic riddle about machines and widgets, shows a 0% accuracy rate. A review of the logs shows the model correctly deduced the answer was 3 minutes, but the scoring failed because the dataset's ground truth was hard-coded with the number 9, a common human intuition error. This illustrates a core MLOps principle. An automated evaluation harness is only as reliable as the quality of its ground truth. If your dataset contains flawed answers, your model's accuracy scores will be meaningless. You now have a fully functional, locally containerized pipeline that is ready to benchmark any AI model you choose. Open the dataset.json file in the data folder. You can now replace the default 20 questions with your own proprietary company data. Subjecting your specific prompts and edge cases to this evaluation is the most effective way to verify the harness's utility for your specific use case. Reliable AI deployment requires more than just successful prompts. It requires a system that can rigorously prove that reliability against a verified ground truth.